Hello, everyone. I hope you guys are all having a great day today. I'm so excited to share with you guys my learning and my journey on Yarn to Kubernetes to modernize a big data workloads on a massive scale platform. I'll start with a quick introduction about myself. My name is Vikas Ranjan. I'm a senior manager of data intelligence and innovation team here at T-Mobile. I am based out of beautiful Pacific Northwest, Bellevue, Washington. I have 18 plus years of experience in data space. Pretty much all my journey has been in and around data, starting from a traditional databases to data warehouses to Hadoop to big data, cloud hyperscale, and building end-to-end data analytics and pipelines and solutions using big data and AI and ML. I am a technologist at heart, and I love to learn and breathe about technology every day at my work and outside the work. In my current role, I am leading and driving one of the biggest hybrid data estate of around 50 plus petabytes of very valuable data estate for solving many different business problems at T-Mobile. On a personal front, I'm a big Seahawks fan. I just love the culture of the teamwork and the collaboration and how we are digging at work every day, learning from the great culture which Pete Carroll and John Snyder has built at Seahawks. In my spare time, I love reading books on technology about different mysteries of life and how I can hone and expand my skills on leadership. And also love spending time with my 10-year-old son, who is intrigued by the history and the word politics, and he loves to share his perspectives with me. You can reach out to me at my LinkedIn profile. I've shared my link over here for anything I can help with post this session. Before I talk about the journey of Yarn to Kubernetes, I would like to share with you guys all what are some of the big data workloads and challenges which we have seen across the industry, and more specifically, I have seen with my experience at T-Mobile over the last many years. At T-Mobile, I have been dealing with some very massive, highly complex data sets. We get data from tons of different, very complex network logs. Those data sets come in different file formats, binary formats, some very specific telco proprietary formats, nested JSON formats, and many more. Highly complex data sets. When we talk about the big data, we truly see every day the volume of data to be a big challenge for us. On any given day, we are processing around half a petabyte of raw network logs coming to us throughout 24/7 in a very complex file-based streaming format. With this data volumes, it brings up this unique challenge of scaling. How do we process and curate and provide nuggets from this high volume data sets when they continue to scale on a daily basis? The businesses of today are looking at the value of data now. There has been more and more ask about how can we leverage the power of big data analytics in the digital world by solving the business problems when the problems are happening, not if the problems have happened a day in past. So the real time is becoming the new right time intelligence now, right? With this huge volume of data, the explosion of data, to harness the power of data, the data reliability has been becoming a pretty big challenge nowadays. How do you make this data to be extremely trustworthy? How do we have this high fidelity and the confidence of the data to make some very critical business decisions, whether it's generating new revenue or reducing the cost or avoiding the cost for the businesses and the macroeconomics of the world we are living in right now. In order for us to solve all those problems in this ever-evolving technology field, in this highly complex big data ecosystem, having the people with the right skills it's an extremely big challenge we are seeing in the industry now, and we continue to find out ways to how do we fill in the gaps on the skills. Well, now I'm going to talk about our journey of this big data, where we started, how we started, what are some of the challenges we encountered, and how do we evolve from there over our journey. In 2015, as we were working with solving some of these network problems for our customers, we were living in the same world as many of the other companies were living in the traditional data warehouses. A lot of analytics, a lot of business decision making, a lot of this, traditional data warehouses used to be in place, and we were in the same boat as others. At the architecture we had when we started our journey of Hadoop in 2015 was a true data warehouse-based architecture, where we were using a traditional data warehouse as a two-system unit. One system was purely to do ELT, get the data from this complex network logs from the different systems, load the data and do the transformations. And then we used to take this transform data and move into a second data warehouse, which was purely serving as our query layer. This was becoming very cumbersome, very painful, very difficult to manage, extremely difficult in terms of delivering our data and insights within our expected SLAs. At that time, since all the industry, everybody was talking about the big data and this Hadoop was becoming more and more prevalent, we also started looking into Hadoop as a solution to migrate and modernize our big data workloads. At that time, we were processing around 2 terabytes of CDRs, call detailed records, for various business analytics use cases. And then this was our first journey or evolution or embarkment of looking into Hadoop to replace our big data problems. It started really well. As some of you guys might be familiar with Hadoop, the underlying core of Hadoop, or what we call as operating system of Hadoop, is something called YARN, which is nothing but yet another resource negotiator. Think of this like a core of Hadoop, where you have a bunch of different Hadoop components. It was stitching all those components together. It was doing workload management to allocate resources, to manage resources. It was a game changer for us, aha moment for us when we started this journey. We saw some really good support for the big data frameworks like Hive and Pig. HDFS as a core storage layer, which was like a traditionally scalable data lake at that time. We could transform the data. We could do some basic queries and exploration of data using Hive. Pig was kind of like a scripting-based ETL tool, where you can basically massage the data, correlate the data, and curate the data. And then in order for us to process some complex network logs, we leverage a custom-based solution built on Apache Storm. It was a really good product. It worked really well for us. However, as we started scaling into, as our scale started becoming from 2 terabytes to 10 terabytes per day, we started hitting the scaling problem. So some of the issues we saw was, again, going from a 2 terabyte to 10 terabyte range per day, we could not really process this data in a timely manner. We started missing our SLAs. We could not scale. Data management was becoming a big of a problem to us every day. We found out very soon that offshore solutions like Pig and Hive doesn't work for the complex workloads we are running into. We used to run. Hive was a really good solution for a basic exploration of data, but as we started applying some complex data warehouse or lab-based functions, Hive was not the suitable tool for that. At the same time, as we were using some custom frameworks, building some custom frameworks on tools like Apache Storm, where we saw not a lot of support coming in, it became very cumbersome and very painful for us to manage, deploy those resources on a daily basis. At that time, we kind of started looking at what are the other options available for us to solve some of these complex problems we were running into. That made us pivot to pivot in 2019 to the hyperscalers. This is where we saw in the mid 2015 onwards, or 2015 onwards, a lot of industries started pivoting more and more, started leveraging more and more power of public cloud. That kind of made us take a first attempt of looking at what the cloud can really help us solve our problems, how it can solve our problem. We started picking up some of our existing workloads, which were running on our Hadoop-based solution at that time, and started not really migrating, but modernizing those solutions in a public cloud. In order for us to kind of leverage the power of cloud for the scalability, you can have infinite scalability. It gives you a lot of elasticity and agility. You don't have to wait for months and months to procure the hardware, build the infrastructure, start building the solutions now. We redesigned our first massive scale data processing engine using 15 terabytes of compressed data network logs using Spark and object storage on cloud. In the beginning, we saw some great benefits of cloud. Cloud definitely gave us all those key benefits in terms of agility and flexibility, as I spoke earlier. We were able to run our applications. We were able to onboard a lot more applications. We were able to start leveraging some of the advanced feature of how do you basically build an end-to-end pipeline? How can you leverage AI and ML? How can you start looking at anomaly detection, start building some predictive modeling? It really gave us that kind of fast-tracked our journey of analytics and evolved our analytics by leveraging all those key principles of cloud in no time. However, during this journey, we also found out, although there is a promise of cloud is infinitely scalable, the notion of infinite scalability literally exists on the paper. We found out with the complex network workloads we have, where we see a huge amount of traffic or the network assets and data sets and transactions and logs and events coming at a high volume to us during the daytimes, and in the evenings and the off hours, we see the workload goes down drastically down. Auto scaling was working really, really well for us when we were scaling up. We could easily able to run our workloads at the peak time with the maximum resources available with the minimum number of work or coding we need to do. However, we could not really gain the benefits of scaling down. We noticed that even though our workloads were 30% or 40% less during the off hours, we were still leveraging almost the same amount of infrastructure resources to process those same workloads. We also found out that Yarn could not really move or consolidate our Spark executors. In other words, again, the scaling up was working really, really well. However, the scaling down was not giving us the benefits as our taste. Developers were also finding it very, very difficult. The paradigm shift of cloud is not the same as doing things on-prem, right? In on-prem, as we know that we have resources fully available to us all the times, and developers are focusing always on building this application without worrying much about the cost or without much about the infrastructure needs. Here, initially, the developers are finding the same challenges. As we were building those solutions on the cloud, developers were having a really hard time to right-size the cluster. Oftentimes, they will build the clusters with a lot more number of resources they actually needed, and we were always underutilizing or building those capacities. It was very, very difficult for us to identify what should be the right cluster size at the time of development when we were dealing with a small amount of data to build our initial developments. And by the time you put the code in the production, it's very hard to kind of find those optimal infrastructure size. At the same time, because we were not able to really see the benefits of scaling down, and then the cost of running the same solution on-prem versus cloud, the cloud turned out to be highly cost inefficient. We saw a lot more spend on the cloud than we used to see on similar solutions on on-prem, because of some of the deficiencies in the infrastructure, some of the deficiencies in the auto scalability, some of the deficiencies we saw in how Yarn was not able to reallocate some of the resources or decrease some of the resources as you were doing things on cloud. At the same time, our data volumes were continuing to increase. We went from a 20 terabytes per day processing or on the cloud to 60 terabytes of processing on the cloud, and another 100 terabytes of processing on the on-prem. So at this point in 2020, late 2021, we were processing around 150 to 200 terabytes of compressed data per day in our hybrid ecosystem. We started kind of thinking through again on what are the other options, what are the other opportunities, what are the other things we can do in order for us to run these workloads, in order for us to solve the business problem we have, in order for us to serve to our business community and our user community. And this is where we kind of started looking into Kubernetes. At that, we were hearing a lots and lots about Kubernetes. We saw tons of benefits of Kubernetes in terms of building a very efficient, resilient microservices architectures. Kubernetes, which is basically a container orchestration tool, was giving a lot of flexibility and a lot of value to the app teams. This was our first foray of kind of taking the power of Kubernetes to build a massively volume, high complex distributed processing engine. It was not an easy journey. I mean, we have to build this solution. We leveraged a lot of open source libraries for deserialization, serialization, for our data processing, looking at a lot of libraries for Parquet versus ORK writers. One of the big reasons we did this period was we wanted to build a solution which can seamlessly work for us for our on-prem as well as for our cloud state with a minimal refactoring. That was one of the key driving principles we had as we started pivoting and started looking into Kubernetes in 2021. This wasn't an easy journey. How did we really go from ideation to realization? I think one of the biggest mantra we had as we were looking into this, as we were kind of whiteboarding, as we were brainstorming, and we were thinking, can Kubernetes really solve this problem for us or not? Because it has not been done other than some white papers we saw. We didn't really have a concrete use case or a concrete success story outside where we could leverage this and best practice and build for us. So one of the things we build in our team has been always a culture of you should have this mindset of fail fast, fail fast. So we did brainstorming, lots and lots of brainstormings, kind of have a war room where we are like working without thinking about how many hours we're spending to build an initial prototype scope, right? We had a very, very small and a nimble and extremely focused team. And their focus was not to worry about cloud operations, the platform operations, the existing data model operations. That was kind of like our tag team, a tiger team with the extremely smart, talented, niche people of 4 people who had a great expertise in cloud, in infrastructure, as well as the distributed processing engine. And one of the key focus we did from the beginning of this was kind of build the telemetry from scratch. I think oftentimes when you are doing this new innovation, when you are doing this new data pipeline development, developers will be focused just on building the functional part of, hey, how I'm going to take the data from one system and transform into other system. Our focus in the beginning was because we were entering into a new foray of opportunities with Kubernetes where we did not really have a lot of expertise. Build the telemetry for application infrastructure from the day one. How do we, looking at the telemetry of our pods, looking at our Kubernetes node, looking at our infrastructure, application, what should be the right size of the pod, how much memory should we allocate to the pod, right? How should we take the advantage of horizontal pod allocation? So the telemetry really helped us along the journey of our POCs in a iterative manner to go and find out how do we optimize, continue to optimize. And then we were, in the end, the results were very, very positive. Within 12 weeks, we were able to really build a production-like POC, successful POC. We were able to run our initial pipeline for around 20 terabytes of compressed network logs per day. And this was a huge success for us. During this journey, we learned it's not about a technology transformation. As you are foraying and as you are entering into this new area of unknowns, you have to have this mindset of how do you learn to unload? Keep your learnings and keep your biases about good or bad, right and wrong on the side. Look at the technology, and look at you with a new mindset, with the open mindset, and then only you can be successful. That was one of the biggest mantra for success for us as we did our POC. From this POC, we kind of evolved and kind of put our first production workload. And then this framework we actually embraced for our second workload, which is around 20 terabytes of raw data per day. But we did not stop after that. During this journey, we kind of trained our people. We expanded our team. We bring in some more backend engineers. We started bringing in some more platform expertise on Kubernetes, started looking at what the other open source community is doing. What are some of the best practices of Kubernetes? How should we look at Kubernetes for network logging? How should we look at other existing tools like Azure Arc, which can give you the benefits of building the telemetry for both the on-prem as well as the cloud infrastructure for Kubernetes, and then expanding this at a high scale problem. Today, we are very happy to say that we have our Kubernetes is used as a primary distributed processing engine for processing around 300 to 400 terabytes of raw network logs with around 20 million files per day in a file-based streaming patterns. Some of the comparisons and some of the results we saw from the initial POCs, we were able to, when we were running our original solution on the Spark, we were using around 250 D-series virtual machines on our Azure infrastructure. And on the Kubernetes, we were able to do the same thing with the 55 F-series machines. So we saw a huge improvement of our infrastructure. The data exploration, the data availability, we improved significantly from 80 minutes availability to around 6 minutes availability. This was kind of like moving more towards doing things now near real time versus doing things in a couple of hours from today. We heavily reduced the dependency on the vendor since we built our initial solution purely on the open source libraries and open source Kubernetes. We were not really leveraging any of the closed loop vendor packages and libraries. We were truly able to demonstrate and take the benefits of auto scaling based on the application load. And we saw less number of platform issues during our initial POC comparison. What were some of the key benefits we gained? As I spoke earlier in the previous slide, the biggest challenge for us was not about scaling up. We were able to scale up really well, but the scaling down was really, really a big challenge for us. With this Kubernetes solution, we were truly able to take the advantage of a true auto-scalable solution. Scale up, add more pods as you need during the peak hours. Scale down, reduce the number of pods when your workloads are going down. And this is all happening automatically. No manual intervention, no changes in the configuration. It was all application-based and leveraging the power of Kubernetes. We saw significant cost improvements. We were able to reduce cost of running our Kubernetes-based processing by 70% from our Spark-based solution. This was definitely a big win for us when we were presenting a value proposition and a success stories to our leadership. We were able to get some great benefits of this across the enterprise, not just within our own team. I think as a developer, last thing I want to do is work at 1 a.m. and solving a production issue. We were able to significantly reduce our operational overheads and improve developer productivity. When you have a developer who is happy at night, sleeping at 9 p.m., not worried about the code is not working, getting up fresh next day, we see a lot more innovation coming from those developers than basically working 24/7. Kubernetes also allowed us to efficiently partition our infrastructure for individual applications. And as I spoke earlier, initially when we built our Kubernetes workload and the POC, it was only running for a one workload. And now we have 3 different workloads running in the same Kubernetes infrastructure to solve the 3 different business problems and bringing all the data together. And that also provided us capability and ability to do a app-based governance and info operations. Now, rather than basically us managing all the infrastructure through a one single operations team, we have this DevOps teams, we have those mission teams who are focused on those particular applications, and they are responsible for the DevOps, the data ops, and the SRE, all functionality within the same product team or a pod team, as we say. In the end, I would like to summarize with some key takeaways. Yarn, when we started with the journey, that was really a good product. It is still a good product. We still see a lot of support in Yarn. There are tons of products and companies like Cloudera's and others who are still using Yarn as a key sort of a core OS for the big data ecosystem and the platforms. We found Yarn to be easy to use because a lot of the abstraction has been done with the services available in the Hadoop ecosystem. You don't have to do a lot of custom coding in Yarn. You can just build some Spark queries, or you can just build some Hive queries and some basic ETL transformations using Pig if you're still using it, right? If we find it to be extremely good for small and less complex workloads with the maturity organizations and the big data platform companies have done now, it works really well for small workloads, medium-sized workloads, and less complex workloads. However, we also found Yarn to be extremely inefficient in terms of workload management in cloud in the last couple of years. We do see it is improving now. It's becoming better now. However, there's still not a very efficient way of managing your workloads in cloud. At the same time, our journey and experience in Kubernetes work really, really well, at least for us, when we are dealing with the high volume, high scale, high complexity data set. It works really well with the custom coding, and there are tons and tons of people contributing to the Kubernetes, a lot of open source community support. We see a lot more, companies like Databricks and GCP and Googles of the world and others who are now even investing more in this space. We truly saw the maximum benefit of auto scaling in Kubernetes than on any other solution, which in turn provide us the most cost-efficient solution for massive scale data processing to meet your SLAs. In our journey, we were able to solve a big problem of Kubernetes with our complex data processing. However, we have not been able to leverage Kubernetes very well for a lot of our complex transformations yet. However, we see that is changing now. There was not a lot of support available of Spark on Kubernetes in the community 2 years back. However, more and more companies are investing to take Spark and run the Spark on containers and use Kubernetes orchestration engine now. It continues to improve. A lot more. Amazon is supporting Kubernetes with the Amazon Spark with the Amazon Kubernetes engine now. Databricks is doing the same with GCP with GKE, and there are other companies doing the same thing now. So it's an evolving space. It's growing, it's increasing. However, at the same time, in order for you to take the maximum utilization and the benefits of Kubernetes for a hyperscale, massive, complex data processing engines, you need some very, very advanced skills. You cannot do Kubernetes with the traditional data engineers coming from the Python background. So you need to invest in your people, you need to invest in your team in order for us to build the most efficient Kubernetes solutions. With that, I want to say thank you to everyone for taking out your time and listening to my talk. And I welcome any questions you guys may have now. Again, thank you so much.